Wasn't that spectacular? Don't worry, it can be explained in physics terms too. Let's take a look.
Is equals to the rate of change of momentum with respect to time, for which momentum is equals to mass times velocity. Thus, concluding the equation of F equals ma. The acceleration of an object depends upon its mass and the magnitude of the force applied to it. When an unbalanced force acts upon an object, the motion of the object changes, and the rate of its change over time is called acceleration. The acceleration of an object depends directly upon the net force and inversely upon the mass of the object. As the mass of an object is increased, the acceleration of the object is decreased.
Newton's third law, you may ask. According to Newton, whenever objects A and B interact with each other, they exert forces upon each other. Formally stated, Newton's third law is, for every action, there is an equal and opposite reaction. And what is momentum? Momentum can be defined as mass in motion. In terms of an equation, the momentum of an object is equal to the product of the mass of the object and the velocity of the object. Consider the collision between a moving 7-ball and an 8-ball that is at rest in the spot of table pool. When the 7-ball collides with the 8-ball, each ball experiences an equal force directed in opposite direction. The rightward moving 7-ball experiences a leftward force that causes it to slow down. The 8-ball experiences a rightward force that causes it to speed up. In a collision, there is a force on both objects that causes an acceleration. The forces are equal in magnitude and opposite in direction. For collision between equal mass objects, each object experiences the same acceleration.
Hughes sports also finds that when two balls collide linearly, the first ball which collides to the second ball will stop. This is also the case of an almost elastic collision, where no kinetic energy is lost. The two balls' equal masses causes them to simply exchange velocity when collided. If the initial velocity of one of the balls was 0, then the one colliding with it would just stop, and the hit ball will take off at the original speed of the incoming ball. However, if both masses are different, then after collision, both velocities will be positive as seen in the video.
One of the most powerful laws in physics is the law of momentum conservation. The law of momentum conservation can be stated as follows. For a collision occurring between object 1 and 2 in an isolated system, the total momentum of two objects before the collision is equal to the total momentum of two objects after collision. That is, the moment lost by object 1 is equal to momentum gained by object 2.